Next we'll examine osmotic pressure, and we'll use the osmotic pressure formula to help us calculate the molar mass of an unknown protein. The osmotic pressure of a solution containing 5.87 milligrams of an unknown protein per 10 milliliters of solution is equal to 2.45 torr at 25 degrees C. Find the molar mass of the unknown protein. Well, this seems like a really challenging problem. Well, let's try to break it down. Big pi is equal to molarity times R times the temperature. So osmotic pressure is equal to molarity times the gas law constant times the temperature in Kelvin. Let's break it down a little bit further and see what information we can get from this. So pi is equal to, remember molarity is moles per liter or moles over volume, times R times the temperature in Kelvin. Let's see what information we have. We have the osmotic pressure, right? We have the temperature, which we can convert to Kelvin, and we have the volume in milliliters, which we can convert to liters. Okay, so from this formula, we can get the moles, and molar mass is equal to, remember, grams per mole, so that's mass over moles. So the moles we can put here, and then we take the milligrams of our protein, convert it to grams, and put it here. And that'll give us the molar mass of our protein. So let's get started. From the osmotic pressure and the temperature, we can get the molarity, and from the molarity we can get the moles, right? And that will be our first step. So molarity is equal to pi over RT, which is equal to, this is our osmotic pressure in torr. We're going to convert it to atmospheres because the R is in liters atmospheres per mole Kelvin. We put in R and we put in 298 Kelvin, which we had to convert, and that gives us a molarity of 1.318 times 10 to the minus 4 molar. Okay, so now we can convert our molarity to our moles. So remember, we had 10 milliliters of solution. Convert that to liters. All right, and then our molarity is 1.318 times 10 to the minus 4 moles per liter, and that gives us 1.318 times 10 to the minus 6 moles. Now, if we convert our milligrams to grams, we get 5.87 times 10 to the minus 3rd grams, and we can put our moles on the bottom, which we just found, and that gives us 4.45 times 10 to the 3rd grams per mole. For practice 14.10 asks us to calculate the osmotic pressure in atmospheres of a solution containing 1.50 grams of ethylene glycol in 50 milliliters of solution at 25 degrees C. So remember, big pi is equal to mRT, where pi is the osmotic pressure, m is the molarity, r is the gas law constant, and T is the temperature. So we just need to do some converting here. So the moles of C2H6O2 is equal to 1.50 grams of C2H6O2 times 62.0 grams per mole, and that's equal to 0.0241663 moles of C2H6O2. Next, molarity is equal to moles per liter, so that's equal to 0.0241663 moles of C2H6O2 per 50. I was going to go ahead and convert it. Let me do it this way. Per 50 milliliters, and we can just convert that in the denominator. 1 liter is 1,000 milliliters. So milliliters cancels, and now we got liters. So that's equal to 0.483325 molar. Okay, so now we have the molarity. The temperature in Kelvin is equal to 25 plus 273.15, so that's equal to 298.15 Kelvin. So pi is equal to mRT. That's equal to 0.483325 moles per liter times the molarity, which is 0.082, times R, which is 0.08206 liters atmospheres per mole Kelvin times 298.15 Kelvin, and that's equal to 11.8 atmospheres.